And let's distribute immunofluorescence testing. This is Dr. JAYAPRAKASH. So, an introduction. The interaction between antigen and antibody complex. The interactions are highly specific and react only with the specific antibodies produced by itself. They have been used in many diagnostic tests for the detection of either the antigen or the antibody by the in vitro method. Antigen and antibody binds through non-covalent bonds in a manner. The physicochemical properties of antigen antibody cocktails: electrostatic bonds, hydrogen bonding, van der Waals bonds, and hydrophobic interactions are the intermolecular forces involved in antigen antibody reactions. Specifically, affinity denotes the intensity of attraction between antigen and antibody complex. Low affinity antibody bind antigen weakly and tend to dissociate readily, and high affinity more tightly for longer duration. Affinity is a measure of the overall strength of binding of an antigen with many antigenic determinants with multiple antibodies. Immunofluorescence. In 1944, Albert Kohn showed that the antibody would be labeled with a molecule that have the property of fluorescence. Fluorescent molecules absorb light of one wavelength excitation and emit the light of another one higher wavelength. So this property also successfully used in immunofluorescence assay. If antibody molecules are tagged with a fluorescent dye or fluorochromes, immune complex containing these fluorescently labeled antibodies can be detected by color light emission when excited by light of the appropriate wavelength. Antibody molecules bound to antigens in cells or tissue sections can similarly be visualized. The emitted light can be viewed with your fluorescent microscope, which is equipped with your UV light source. Fluorescent compounds such as fluorescein, rhodamine, phycoerythrin, intensely colored and highly fluorescent pigment obtained from algae. So the phycoerythrin, which was obtained from the algae, Rhodophasiae family algae. Each of the fluorochromes absorb light at one wavelength and also emit light at your longer or visible range. Fluorescein, an organic dye that is the most widely used label for immunofluorescence procedures, absorb blue light approximately 490 nanometer and emit and enhance yellow-green fluorescent rays nearly 5.7 nanometer. The rhodamine, another organic dye, absorb in the yellow-green orange 5.5 nanometer and emit a deep red fluorescence 546 nanometer. It emits fluorescence at a longer wavelength than fluorescent. It can be used in a two-color immunofluorescence assay. An antibody specific to one determinant is labeled with fluorescent. An antibody recognizing a different antigen is labeled with rhodamine. Phycoerythrin is an efficient absorber of light, approximately 30-fold greater than fluorescent dye, and a brilliant emitter of red fluorescence. Stimulating is widely used as a label for immunofluorescence. Immunofluorescence tests have wide applications in research and diagnostics. These tests are broadly of two types. One is direct immunofluorescence test and another one is indirect immunofluorescence test. The first one, direct immunofluorescence test. It is used to detect antigen in a cell or tissue by employing known-labeled antibody that interact directly with the unknown antigen. If antigen is present, it reacts with the labeled antibody and the antibody-coded antigen is absorbed. And the UV light of the fluorescence microscope. Direct immunofluorescence test is widely used for detection of such organisms like bacteria, parasites, viruses, fungi. Other antigen in CSF, blood sample, stool sample, urine sample, then tissue and other specimens. It is a very useful test for antenatal diagnosis of rabies by detection of rabies virus antigen in the skin smear collected from the lab of the neck in a human and in a saliva of dogs. The test is also used for detection of Yersinia pestis, the Quadrivectinium bacteria, Trigonema pallidum, etc. Directly inappropriate regular specimen. Disadvantage: the need to prepare separate label antibody for each pathogen. So the image is simply depict direct immunofluorescence and indirect immunofluorescence. So the direct fluorescence test, antibodies are conjugated with fluorochromes. Then after the antibodies also directly applied to the clinical specimens. If the clinical specimen tissue contain any antigen, so the label antibodies can directly bind with antigen. Then this will be viewed with the help of UV collector or immunofluorescence microscope. The second one, another one is also known as indirect immunofluorescence test. So immunofluorescence test, then antibodies, they are using also secondary antibody conjugated with fluorochrome. Then after the secondary antibody also known as a fluorescent antibody. Then initially the patient serum, so the patient serum also denoted as primary antibody added with tissue sample. Then after the secondary antibody also highly specific to primary antibody. So the secondary antibody already conjugated with the fluorochrome. So the fluorochrome conjugated secondary antibody binds with only the primary antibody, not antigen. So this is the indirect. There are direct and indirect. There are only the few differences. If they are using secondary antibody, so that the test also known as indirect immunofluorescence test. So, indirect immunofluorescence, it is used for detection of specific antibodies in the serum and other body fluids for serodiagnosis of many infectious diseases. And known antigen is fixed on a slide. Then the patient's serum to be tested, which is unlabeled, is applied to the slide, followed by careful washing. If the patient's serum contains antibody against antigen, it will combine with the antigen on the slide. In the second stage, the combination of antibody with an antigen can be detected by addition of fluorescence dye label antibody to human IG and examined by a immunofluorescence microscope. The first step in the indirect immunofluorescence test is the incubation of a fixed antigen with unlabeled patient serum, which become associated with antigen. The next, after careful washing, the fluorescent antibody is added to the smear. This second antibody associated with the primary antigen antibody complex and visualized on the fluorescent microscope. This test is used widely to syphilis, leptospirosis, amoebiosis, and toxoplasmosis. And then a single label antibody to detect many different specific antigen antibody reactions.